Hello everybody, so in this video we're going to be looking at how to automate the process of updating your rigs. Now, there's many different reasons why you want to update your rig, but typically it comes down to the process of your features of the rig or have changed, or you fixed bugs that your animators have picked up, or you've updated ZooTools to the next version of Hive and now you need to update. When we make changes in Hive, whether it's you or me as a developer, some of these require certain operations to be done by hand before you essentially go through and deliver it to your animator. This means that we might add new guides that need to be manually placed and updated. In most cases, and what we've done with Hive at the moment is we're trying to automate this as much as possible. But in some cases, it's not always a viable solution. So what we need to be able to do is being able to have a faster process to do updates. So what we want to be able to do is say, if I've got 10 rigs or 100 rigs or 1,000 rigs, I want to try to minimize the amount of work involved in that update. Now, if you're in a lucky situation where you're using the same template for multiple rigs, which I hope you are, because it's a lot of pain to update rigs, then what you can do is leverage a tool in Hive which allows you to update a rig from a template. So the first thing I'm going to do with this scene with Zoom Mannequin is I'm going to remove a feature from the rig, because we've already updated this rig with the latest features, but now we want to remove some. We want to downgrade it a little bit because you may not need that feature. And for demo purposes, it's a very simple thing to do. So we're actually going to remove the bendy feature of the left leg. So it's the only one that doesn't have bendy. So the first thing we're going to do is go into the Hive Artist UI. And I'm going to show you how to do this manually for the UI in the update process and what the limitations are. Then we're going to write a script from scratch that will do this update for you, which basically just runs the same functionality as what the UI does, but without the main limitation that the UI has. So what we can do is I'm just going to go back to guides, and I'm just going to do this without time-lapsing the video, so that way you can see how long it actually takes to build this thing. And we're going to go and select one of the guides on the leg, and I'm just going to click this button up the top here. And now I'm just going to remove bendy and just go back to twist. So now we have no bendy, and now what we can do is save this guy out. So I'm just going to call this, Zoom Mannequin new. And now, if we have a look at this, we have Zoom Mannequin new at the bottom in the template section here. And what we now want to do is load the same scene again and apply an update. I'm only doing this for demo purposes, but this is how we're going to work. So, easy way of doing this, because I've already got the scene saved in asset browsers. If I can find him again. Yep, that one. So I'm just going to discard and open again. So same scene, currently contains bendy. What I'm going to do is go into the template section, right click on Zoom Mannequin new, or you can go to the dots menu and just go update rig from template. And it requires you to save the scene. I've already done that, so it's fine. And I'm just going to discard. And what it's going to do in this process is it first understands which build mode you're in. That way you maintain the same state. So if you're delivering a rig to the animator, it's really important to be in polish mode. I will go through the build stages and what they really mean at a later date. But we want to be in polish, and what it's going to do is log that and say, hey, you're currently in polish mode. Then what it's going to do is go back to guide mode for you. So when that happens, it's going to also delete your entire rig. So all of that happens. Now, if you have build scripts attached to the rig for the template, it's also going to run the necessary functions relating to the build script and the deletion process. That way you can make sure you detach your own custom rigs or anything else. Once that happens, you now no longer have a Hive rig in the scene. Well, you do, but you don't have the actual animation rig in the scene. The next thing it's going to do is purge your metadata. So this means it's purging everything relating to the rig. The only thing it maintains is your joints and your deformation. Hive doesn't know about deformation so much. I'll definitely get into the specifics of what deformation currently means to Hive, and it's mostly just relating to how it maintains that. and how it updates the joints. But it doesn't know about any of that. So all your deformation is maintained. Once this happens, it's then going to actually rebuild the rig from that template by recreating all that metadata with the template information. It's then going to go and do a full build of your template and a full build of your rig, and now you're going to build the polish and go back into polish mode, and you're done. That's essentially what it just did for you, and it does in a few moments, maybe less than 10 seconds for something like mannequin. And it includes the entire delete process and the rebuild process. Then what I'm going to do is just select the knee here, and now we have no bendy here, and if we go into the right leg, we do have bendy. So we now know that the entire rig was updated. So we absolutely do know that rig works, skinning is maintained, all that kind of stuff. So this is the process that we want to do. But what are the limitations of this? This is a UI limitation, and that is the rig names of the components must match. So if you rename one of these components to something else in the template, because you want to, like, let's say we had this situation with one of the rigs, which is we had the God component, which is like the master component if you're used to that naming convention. The God component was called the God node component, and we wanted to change that to just the God, right? This would mean that the update from the template in the UI wouldn't work, and that's because it does a component name match. So it goes God M, spine M, clavicle R, for right to left and so on. It matches those from left to right, from the template to your actual rig. Unfortunately, with the UI at the moment, we have that limitation. This is something that we will be working on, but the code doesn't have that limitation. And the reason being is because you can feed that information into the code to say, hey, this is my old component, this is my new component. So now we want to automate this. The question is, how do you do this? So what I'm going to do is go into PyCharm. Next thing I'm going to do is create a Scratch file. So I'm just going to File, Scratch, and let's go Python. So we're going to be writing every single line here, just so you can see it. I'm not going to time lapse it. It's actually a pretty small script. It's going to be under about 60 lines of code, including the actual call to the function roughly. The first thing I'm going to do is just import OS, because we're going to need to know we're going to need to check to make sure the template exists on disk. I'm just going to zoom in so you can see a little bit better. Next thing I'm going to do is import zoo for actually util and import file system, because we're going to need to be able to load JSON data, and I'll explain why. We don't actually need to manipulate the JSON data unless you really want to, but that's also the power of it. So I'm also going to import the ability to load, open a Maya file and save Maya file. So we have that underneath the file section module. And the next thing is I want to import the Hive API. Now I have GitHub Copilot, so it's auto-completing quite nicely for me. Next thing is I'm going to create a logger. It's basically a child of the Zoo logger, which means that our configuration kicks in and our tools for showing debug mode and so on will work. So the first thing, I'm going to create a function that needs to find the rig in the scene, right? We have a rig, but we need to be able to initialize that in Hive. So I'm going to create a new, it's just did it for me because I've already wrote the code for what this does. And I'm just going to autocomplete. I'm also going to add in the namespace here too, because it's going to do that for me. So exactly what is this doing line by line? So the first thing is just check to see if the name is in the scene. If it is, I'm going to get the root by name. What exactly does root by name do? It will essentially loop over the scene trying to find a very specific set of nodes. And those are essentially our meta nodes. Those are essentially Maya native nodes. The node type is a network node, and it's got a particular attribute on there for stating what kind of type it is. Underneath the hood, root by name. If I just grab that, put it in here. It's a bit of a long, decent function here. So it's just going to loop over the scene, all the scene meta nodes for the rigs. It's then going to gather those rigs for you, and also just grab the rig names as well. That way it's just for mapping. And it's just going to return that particular rig meta node, right? If it matches your name, right? If it matches this name, it's going to return it. So in that case, it's only going to return you the meta node. It's not going to return you the rig instance. But the meta node is what we call the Hive rig meta node, and we'll definitely get into the metadata at a later date, but it's going into more advanced Python and concepts and so on. So I'm going to return the rig instance, and this is a really fast way of doing things because you're not initializing the rig from the scene at this point. All you really need to do is grab the meta node, pass it in, and that's it. All right. Next thing is, if that doesn't happen, obviously we raise an error. Next thing is, well, if name doesn't pass, we're just going to loop over the scenes, the rigs instances in the scene, and just return the very first one. Next thing we're going to do is create another function that does the actual update. So yeah, since I've already wrote the code, it already knows about it. So no, don't autocomplete for me, please. I'm going to change this to take a rig instance. Call this rig and pass in a template name. That's going to be the template that we're going to be using. And the first thing I'm going to do is going to log debug mode, debug. So updating. It'd be nice if I could spell today. Template. Next thing is we're going to be able to get the actual template itself. Now, there's multiple ways of getting templates, and there's a reason why I'm passing and getting access to the file system and loading the JSON data is so that you can provide a raw JSON data file. This means you can put it anywhere on your system and load it directly from there. But what I'm going to do right now is only support the template name. This means it's part of our registry already. So to do this and get access to that, I'm just going to get access to the rig, and I'm just going to go to configuration, because that's where our template registry exists. Grab the template registry, and that's going to be our registry. And next thing is we're going to now get access to our template. And this takes in the template name. So in this case, it's going to be our ZooMannequin _ new template name. Now we're just going to double check to make sure that it exists. So in this case, make sure it does. So next thing, I'm just going to log that to make sure that we are saying when we need to turn on the zoo logger, say, hey, just output the debug, at least know that I can trace that and say, this is the template it is. It also means that when I'm on render farm, these logs will go out as well, just because only if you do turn on the debug mode, which is, I always recommend doing that on the render farm as much as possible. The next thing is I'm going to pass in remap node data. I'm just going to initialize that to an empty dictionary, and I will actually pass that in as a variable. Actually, let's just make that a requirement. Now you might say, what is remap? And we'll definitely touch that, because that's the limitation that the UI has, is we don't have the ability to remap. Next thing, we want to actually update the rig. So we have all the information, now we just need to update. So I'm just going to go API commands and update rig from template data. So it takes the role, and what we're then going to do, it's got everything that we need, but we're missing the template data, right? So this is where file system load JSON template path, and that obviously takes the actual file path itself, and I'm just going to call that template data. And that's all we need to do. That's everything that we need to worry about. So it'll raise any errors, log any information that it needs to worry about. I'm going to leave any safety checks and concerns that you have around potentially it's crashing, or potentially there's a particular rig problem that you need to worry about, validation, and so on. I'm not going to go through that process because that's just standard Python code. I'm also going to create now another function which I'm just going to call this. I'm just going to take in a input scene file, so that's going to be our Maya file to load, and the output scene file. So, well, in this case, scene file, rig name, and template name. Now I'm just going to copy some code over here for calling this function. Don't do that. And I'll explain that in a moment. I'm just going to go file.open file. Open file. That's going to take our Maya scene file. I'm also going to do file.save scene. And I'm now also going to grab the rig instance, do from template functionality and function. I'm also going to pass in the pretty map data for this. And in our core function, we're just going to initialize that to 0. I mean, to empty dictionary. Going to zoom out so I can see a bit better. Now we want to call this. We're just going to pass in the location of that file. So I'm just going to come back to Mile. I'm just going to go to the browser, and I'm just going to grab the location of that. And I just want to output it. So I'm just going to put that there. So, bad naming mentioned, but that's a fine. Then I'm just going to grab the rig name, so it's just Zoo Mannequin. And the output, the template name, I think, is just what we do for the template. So Zoo Mannequin new. So now we've done everything, I'm just going to copy paste this into Maya. So I paste it, and then I'm going to execute it. It's loaded the scene. It's loading them. It's now updating. It's going back to guide mode. It's now updated. It's now saved the file. So I'm just going to go back to here, new scene, import that guy in. And that template is the right one. Yep. So we have no bendy, so it's removed the feature that we added and that we've removed in the template. And if we go to make sure the other leg is right, now we have bendy. With this, we've automated doing a rig update, but we're only doing this directly in the script editor. Now you could take this an extra step further by creating a for loop and then looping over the in scene and the out scene, as well as the template that you want to use for each one of those scenes. That will allow you to batch automate the process relatively quickly. But you could take it even further, which is something that we do in Zoo, which is to do this all through PowerShell or command line script or Bash if you're on Linux or OS X. In this way, you would be able to support things like render farms. Something that you use quite often in production is the power of render farm, where you've got hundreds of machines and you got proper scheduling and so on. So that way you can submit hundreds of rigs all at once by just doing a simple template update, or you have a small code change to your actual components, and now you can just, you want to push this all out to the entire production. This is a perfect way of doing it. Now, obviously, we haven't dealt with deformation, so things like skinning. This is something that you probably want to take care of. You could even go further than that and then say that you're going to rebuild the whole scene from scratch. So importing the actual template, importing the geometry, and then importing all the skin weights. And then you would have a fully functional full update process, which would take into account of your UV changes and mesh changes and so on, as long as you're dealing with skinning to a reasonable level. You can even go even further by an extra step further right at the end once you've actually saved out the scene, which is spit out a turntable as well. That way you can do validation of the actual rig after the fact if you have a ROM test. So that's essentially it. We're not going to take it any further with this. We're going to go on to the next set of things for Hive. If you really want me to go through the command line integration, then I can by all means do it. I'll do it in another video. Just let me know in the comments and I'll get it done.